Today we're going to start this video off with a question. I'm going to show you a couple pictures. I'm going to ask you a question about them, alright? Ready? Here goes the pictures. Oh, I'm sorry. Was that a little fast for your slow eyes? I'll show you the pictures again, but this time pay attention. So the question is, does this picture right here have more shading than this picture right here? If you think it's a trick question, that's because it is. See, we're taking the same circle and we're breaking it up into a different number of equal-sized pieces. In this case, we're breaking it up into 12 equal-sized pieces, and we're shading in 4 out of the 12 pieces. That makes this circle represent the fraction 4/12. Now in this other picture over here, we're taking the same circle and we're breaking it into a different number of equal-sized pieces, this time 4. Now since we're only shading in one of those pieces, this circle represents the fraction 1/4. And as it turns out, if you shade in 4 out of the 12 pieces in the first picture and 1 out of the 4 pieces in the second picture, you get the same amount of shading in the circle. This tells us that the fraction 1/4 is equal to 4/12. Now today's video is going to be all about taking that 4/12 and turning it into the simpler 1/4. Let's go ahead and shut our yaps and take a look. Alright, so obviously today we're going to be talking about a topic that's very near and dear to my heart, and that would be simplifying fractions. There's lots of ways to do this, but today we're going to focus on something called the prime factorization method. Now this particular method is useful for us when we don't really know a whole lot about the numbers and we just want to try and get straight to the answer. Another advantage of this is that if we do our prime factorization correctly, then it's going to get us to the most simplified answer straight away. The trade-off, of course, is that sometimes this particular method is going to take a little bit longer than if we knew stuff about the numbers ahead of time, but, at least we're going to be accurate. So how do we do this? Well, to simplify fractions using the prime factorization method, you obviously have to find the prime factorizations of the numerator and denominator separately. We're going to replace them in the fractions with their prime factorizations. We'll cross off any common terms between the top and the bottom, and then once we're done doing that, we just have to multiply what's left in the top and the bottom separately from one another. Let's take a look at this example right here. Here we're asked to simplify 140 over 150. We're going to start by finding the prime factorization of the numerator and denominator separately. This means we got to try and find the prime numbers that when you multiply them in any order are always going to end up in 140 or 150. The easiest way to do this is to use factor trees. Factor trees ask us to keep dividing the number until we basically can't divide no more. So let's go ahead and take a look at how we do this with 140. We start by thinking of two numbers that multiply to 140. Doesn't matter which ones, but for the sake of easiness here, let's call it 14 times 10. We'll do the same thing for 14. 14 is 2 times 7. I'm going to underline these two things because they're both prime. We do the same thing for 10. 10 is 2 times 5. I'll underline those as well because these are also prime numbers. Now I can't break any of these numbers down any further, so I found the prime factorization of 140. It's 2 times 2 times 5 times 7. Let's do the same thing for 150. Think of any two numbers that multiply to 150. Now for me the easiest pair is going to be 15 times 10. Neither one of these are prime, so we can break them down further. 3 times 5 is 15. These are prime, so I'm going to underline them. I know I can't break them down any further. I could do the same thing for 10. 10 is the same as 2 times 5. Once again, my two prime numbers here. I can't break anything down any further. This gives me my prime factorization. We get 2 times 3 times 5 times 5. So now that we got our two prime factorizations, we can return to our fraction and replace the numerator and denominator with those prime factorizations. 140 we just found out is the same as 2 times 2 times 5 times 7. And now we're going to do the same thing for 150. We found out that that's 2 times 3 times 5 times 5. So now we cross out anything that shows up in the top and the bottom, like these 2's here and these 5's here. Once we're done with that, we can just multiply what's left over in the top and the bottom to get our simplified fraction. 2 times 7 is 14. 3 times 5 is 15. That means 140 over 150 is the same as 14/15. Okay, so let's try one more here. Let's simplify 24 over 60. Once again, we'll find the prime factorization at the top and the bottom. We'll replace, cross off, and have a nice day. So we get 24, which breaks down into 12 times 2. I see that I have a prime factor of 2, but 12 can be broken down more. 12 turns into 6 times 2. Once again, my 2 is a prime factor, but I can break down my 6 a little bit more. This gives me 3 times 2, and these are both prime, which means now I have my prime factorization. I'll list my numbers in order from least to greatest. 24 is equal to 2 times 2 times 2 times 3. Let's do the same thing for 60. Here's a tip for you. If your number ends in 0, you can always divide it by 10. So that's why I'm going to turn 60 into 6 times 10. Neither one of these are prime, so I'm going to break them both down further. 6 is 2 times 3, which are prime now, so that's done. I'm going to do the same thing for 10. 10 is the same as 2 times 5, and these are both prime, which tells me that 60 is the same as 2 times 2 times 3 times 5. So with our prime factorizations, now we can go back to our original fraction, replace, and then cross out. Ready? So we get 24 over 60 is the same thing as 2 times 2 times 2 times 3 for 24 over 2 times 2 times 3 times 5 for 60. Now we're going to go ahead and cross off anything in common. That would be these two twos, and these threes. I'm left with just a 2 and a 5 in the top. That makes simplifying super easy. 24 over 60 is the same as 2/5. Alright, so that's the prime factorization technique. You take your numerator and denominator, find their prime factorizations, replace them in the original fraction, cross off anything that they have in common, multiply what's left over, bada bing, you got yourself the simplest form of your fraction. Obviously, this takes a lot of time, so the key question that you should be asking yourself is, do I need to be doing this every single time? And the answer is, well, what I said at the beginning of this. Use the prime factorization technique when you're not really too sure about the numbers and you just want to get straight to the answer. Of course, if you're comfortable working with each number and you know more or less about the factors of each one, then you really don't have to go this far. But it's an option. That's what I'm selling you here, folks. It's an option. So yeah, that's simplifying fractions for you. If you want to get good at it, of course you got to practice. You can't just look at this video and be like, I got it now. Go out and practice. Jeez, I'm busy. I gotta go. Later.